When we first begin the simulation, we see that the man has no difficulty resolving the trees in the distance. They appear very crisp and clean. These trees are around 20 meters away, which amounts to 20,000 millimeters. So he has pretty good distance vision. For very distant objects, rays emerging from any point on that object will appear parallel by the time they reach the eye. We can see that in the diagram at the top of the simulation. These two rays came from the same point on one of those trees. Let's assume the tip of one of the trees for now. The two rays are focused onto the retina of this observer. That's a good thing, as that means these two rays, which both emerge from the same point on the tree, are focused onto a very narrow part of the retina, only activating a small number of cells in the retina. What would happen if this observer had poor distance vision? What would that mean? Let's try changing the focal length of the lens in his eye, so that the rays from the tip of one of those trees focus at a point behind his retina. Let's make the focal length of the lens in his eye as long as 18 millimeters. Do you see that the trees now look blurry? This is because where the two rays impact the retina, before they focus, they are likely activating many of the light detecting cells in the retina, and the tree looks blurry as a result. What can we do to fix this? Maybe we should add a contact lens. Adding a converging lens with focal length 150 millimeters solves the problem. The lens makes a small adjustment to the path of the rays. The longer a lens's focal length, the less impact it has on the path of rays. In this case, we are taking an eye with focal length 18 millimeters and adding a lens with a focal length 150 millimeters, a small adjustment. Not all lenses need to be converging. We can add a diverging lens, a concave, rather than a convex lens, as a contact lens. This spreads the rays out rather than brings them to a focus, and this helps push the focal point farther back. This is useful for people who have eyes with focal lengths that are too short. You can also put objects at different distances. If we choose an object that is much closer than the trees, the rays are not initially quite so parallel when they enter the lens. This means more deflection is required in order to focus them, and a different kind of lens system is needed. So try playing around with different objects and different distances, using different types of lenses and with different eye lens shapes. See what you can figure out, and thank you for watching.